Hey, welcome back to Math with Patrick. Today is June 25th, and we're solving problem number 176 from the Daily Epsilon calendar. And we need to find the smallest square that can be written as a sum of two integer squares. So when it says find the smallest square, we basically just need to find different square numbers, like maybe 1 squared or 2 squared or 3 squared, so that once we evaluate it and get like 1 or 4 or 9, we can then write this number as a sum of two integer squares. And the integer part here just means that we're going to use some kind of whole numbers here. So if you try creating, say, this square number and try writing it as the sum of two integer squares, well, there aren't really any lower numbers to choose. And I know that 1 plus 1 does not make 1. And then same thing here, if we have the number 4 and we pick two other square numbers to add up to this number, really all we could do is try to use two ones, but it's not going to get to 4. Same issue kind of here, 1 plus 4 isn't equal to 9, and we just don't have any good sums of square numbers just yet. With 4 squared, we get 16, and any combination of two squares that we try to use won't work. You'll maybe notice that 4 and 9 together make 13. That's too small. And then if we try using the 1, that's even smaller. So once we get to 5 squared, I believe this is going to work. The Pythagorean theorem might be familiar here. Oops, I meant to do 3 squared. Where this is the smallest Pythagorean triple, the 3, 4, 5 triangle. It is a very common right triangle that comes up in math, and this triangle is saying hello to us in the problem today, because once we find 5 squared, which is 25, we can write it as 9 plus 16, and those are some previous square numbers. So the smallest square that can be written as a sum of two integer squares is 25. And that's the answer today. So we're all done. You can say bye to Quilly now. And we'll see you tomorrow. Bye.